Okay, so now we're going to talk about converting from polar equations into rectangular equations. Okay, so we're going to go the other way. So we just need to remember that you can always bring in an x if you have an r together with a cosine. If you have those together, you can switch it to an x. If you have r and sine together, you can switch it to a y. Okay, and then if you have r by itself, it just becomes the square root of x squared plus y squared. And then if you have r squared in your formula, then that is just equal to x squared plus y squared. Okay, so remember the r equals 3. Those are the concentric circles. So this should be a formula for the this should be the equation of a circle with a radius of 3, right? So r is equal to this, so I can plug that in. So I'll do that. This is equal to 3, and then I square both sides, and I get x squared plus y squared is equal to 9. And yes, indeed, that does give me a circle here, centered at the origin, with a radius of 3, because the formula is x squared plus y squared is equal to r squared, right? So that's converting that there. Now, something like this, these two, I put these up because these are kind of special cases, and the way to do these is write that like this. So 5 secant theta, write that over cosine, and then multiply both sides by cosine, bringing it up like this. And then when you get an r and a cosine together, it becomes x. So now you got x is equal to 5. So this is really the formula for a vertical line. Okay, for the vertical line, x equals 5. Okay, and another thing is, oftentimes if you have r is equal to something and you have a trig function, a sine or a cosine on bottom, you can't just put an r in there on bottom. You can't do that. You can't. It doesn't work like that. Normally what you do is you bring this up to the other side so that you can get the r and the cosine together like we did here. Okay, this is similar to that. R is equal to -2 over sine theta, and then I can bring the sine up is equal to -2, and then you have an r and a sine together, you get y is equal to -2. So this is the horizontal line, y equals -2. So that's what you do in either of these cases. Okay, so now if I have this, okay, here I got the cosines and sines on bottom. So what I want to do is I want to get r's together with the sines and cosines. Sometimes that involves multiplying both sides by r, but you can't really do that very well here. So what I'm going to do is I'm going to bring this up to the other side, like this. And that's equal to -1. And see, I can then distribute that r here over like this. And then I get an r and a cosine together, which becomes 2x. And then I get an r and a sine together, and that becomes, this will become 5y is equal to -1. So this is really the equation of a line. And if we remember, I've just done backwards the problem where I was given the rectangular equation of a line and I converted it into a polar equation, and it looked like that. So this is kind of doing it backwards. I brought that to the other side, distributed the r over, and then I was able to switch both of those back to x and y's. Okay? Okay, now this one's a little strange. So what I want to do here is I want to get an r with this sine. I gotta have an r with a sine or a cosine in order to convert that to an x or a y. So what I'm going to do is I'm going to multiply both sides by r. So that would be r squared, and this would be r times all this. And then I can distribute that r over 5r minus 3r sine theta. And so now what I get here is I get a y there. Okay, the r squared, remember that is just x squared plus y squared. Okay, and then an r by itself is the square root of x squared plus y squared. Okay, so these come back to the definition of r being the radius, right? Using the Pythagorean theorem. Okay, and then r squared is that. So I get this, and then this is just minus, and that becomes y, 3y. So this is just a really weird equation involving x and y. Certainly not a function. It would be very, very difficult to graph. You could probably graph it on Desmos or something like that. But that's what you would get. Okay? And then this is going to be our final one. That looks pretty simple, and it's really not too bad. But what I want to do is I want to get an r together with that cosine. So I'm going to square both sides. I'm sorry, I'm not going to square both sides. I'm going to multiply both sides by r, and then I'll get this. So to get bring an x in, you have a cosine theta, you got to get rid of that. You need an r there with it, so you can bring in an x in that case. So I'm going to multiply both sides by r. This becomes x squared plus y squared. And this just becomes 6x. And now this basically is formula of a circle, but I need to complete the square. So what I did is I brought the 6x over here. Oops, this should actually be a minus. So, sorry about that. That should be a minus. So what I did is I brought the 6x over to the other side. In fact, I kind of, let me actually do it in a couple steps. So I'm going to bring the 6x to this side, like that. And what I'm going to do is I'm going to complete the square here. Okay, so to deal with this. And this is back when we learned about formulas of a circle. So I'm going to add something and I'm going to take something away. Plus y squared is equal to 0. So what do I add and take away to complete this square? It's half of the coefficient on the x squared. So half of the 6 is 3, and then squared would be 9. And so then I'm going to take away 9. So I'm adding and subtracting so that this thing can be reduced to x minus 3 quantity squared. Okay, and then I'd have the minus 9 plus y squared is equal to 0. And then I can move the 9 to the other side. X minus 3 squared plus y squared is equal to 9. So this is basically a circle with a center of 3, 0, and a radius of the square root of 9. So a radius of 3. Okay. Yeah. Yeah. So what I can do then is I could draw this circle if I wanted to. So the center is here, and then the circle is this, it's centered. So it actually has a diameter of 6, right? The diameter is 6, the radius is half of that. Okay, and it's moved over on this axis. It's just like I was talking about in the previous section, how anything like this gives you a circle, okay, that's shifted over. So what I was going to say, I can kind of show you something here. R is equal to, if this were A cosine theta, and I had R is equal to A sine theta, these two, this will always be a circle, okay, and it'll always have the radius of A. It'll always be I'm sorry, it'll always have the diameter of a, so this will always be a, this will always be half of a, and the radius of the circle is half of a. So this would be if a was greater than 0, and it would be on this other side if a was less than 0. This would be a, this would be half of a. Okay, this would be if a was less than 0. You'd have a circle over here. And so this is for cosine, right? And then if you had a sine, okay, this would be a. This would be when a is greater than 0. This would be half of a. And this thing would go like this. It would be a circle like that. And if a was less than 0, you would have this. This would be negative a. This should be negative a here. And this would be negative a over 2. That's negative a over 2. Okay? And so this is if a was less than 0. So if the a was negative, you'd get a circle below the axis. This is if it's sine. If it's positive, it would be above the axis. The diameter would be a. The center here would be a over 2 on the axis. And if it were a cosine, then it's a circle. If a is greater than 0, it's over here. If it's less than 0, it's over there. And that's one of the things that you learn when you start talking about the graphs of these. That's what these functions are. Okay? So, so this had a little bit of completing the square in there so that you could see that indeed it was a circle that was shifted over that had a radius of square root of 9. So, okay. So that's converting from the polar equations into rectangular equations. So now we'll talk a little bit about graphing polar equations.